special systems of linear equations. We've already kind of talked about this a little bit as we've gone through our methods of solving systems of equations, but we're going to talk about it a little more in depth today. So yeah, let's get to it. Numbers of solutions of linear systems of equations. There's only really three options. A system of linear equations can have one solution, no solution, or infinitely many solutions. Do you guys remember talking about no solution and infinitely many? Okay. One solution is just where our lines intersect at one point. That one point is our solution. If the lines are parallel, are they ever going to intersect? No. So if I'm looking for the point of intersection, but they don't intersect, I've got no solution. Everyone good with no solution? And then infinitely many solutions. If I have two lines that are the same, they're graphed right on top of each other, they're intersecting at every single point. Does that line ever stop going in either direction? No. So it's got an infinite number of ordered pairs on that line, so it's going to intersect at every point, so I have an infinite number of solutions. So you can have one solution, no solution, or infinitely many. And of course, with our one solution, is that ordered pair always the same? No. It could be any ordered pair, just wherever those lines intersect. Okay? Any questions about the numbers of solutions we can have? One, no, or infinitely many. Those are your three options. Am I good to move on, or is anyone writing this down? You writing it down? Okay, I'll give you a few seconds. So how the notes will work today, and I have two examples for you. We're going to solve each of them using all three methods though. Graphing, substitution, elimination. That way we can see what no solution looks like for all three methods. We can see what infinitely many solutions looks like for all three methods. Okay? So here's example 1. Y equals 2x plus 1. Y equals 2x minus 5. Before we get into this, what do we know about parallel lines and their slopes? They're the same. So if I have two lines that have the same slope, do they have the same y-intercept? No. So if they have the same slope, but different y-intercepts, I know they're parallel, right? On your assignment, you will have some problems where you just have to look at the slope and y-intercepts to determine how many solutions there's going to be. Infinitely many solutions. These two lines will have the same slope. What about their y-intercepts? Same. They will also be the same. So same slope, same y-intercept, it's infinitely many solutions. Now if they just have completely different slopes, if they have different slopes at all, it doesn't matter what their y-intercepts are at that point. You could have the same y-intercept, you're just going to have one solution. Because you know they're not parallel, you know they're not going to be the same line if they have different slopes. Okay? Does that make sense? Yes. Okay. Okay, now to example 1. How do I solve by graphing? Let's graph first.
You go up one on the y-axis.
Yep, because the y-intercept of my first line is 1. So that's my starting point. Put a point at 1 on the y-axis. What's my slope of the first equation?
2 over 1.
2 over 1. I use my slope to get more points on my graph. If it's a positive 2 over a positive 1, rise over run, which two directions and how many units would I go?
Up 2 over 1.
Up 2, right 1. How many points do I want you to have?
As many as you can get.
As many as you can fit on the graph. Is that as many points as I can fit? No. What other two directions can I go? Down 2, left 1. And we're able to do that because we can change both the signs of our numerator and denominator. I can now connect my points. Where are you confused at?
At the dots.
I'm solving by graphing, so I'm graphing my first equation right now. Okay? Y equals 2x plus 1.
Right, I know that, but how do you get to that and then?
So our y-intercept, we said, was 1. So that's where it's crossing my y-axis, so I put a point at 1 on the y-axis. My slope is 2 over 1, so I'm using that to get more points. So from my y-intercept, rise over run, I can go up 2, right 1. That's how I got these points to the right of my y-axis. Okay? Changing the signs of both my numerator and denominator, does that change my slope at all? No, because a negative divided by a negative still gives me a
Positive.
positive, but now it helps me get more points to the left of my y-axis. I can go down 2, left 1. Does that help?
Yeah.
Okay. Okay, second equation. What's my slope?
2 over 1.
2 over 1. Y-intercept?
-1.
Negative 5. So, once again, my y-intercept will be graphed first. Go down 5 on your y-axis. Put a point. That's your y-intercept. And once again, which two directions am I going?
Up 2 over 1.
Up 2, right 1. Just keep doing that until you run out of room. And once again, which other two directions can I go?
Down 2, left 1.
Down 2, left 1. Here's my 2 lines. What do we notice about the 2 lines? Parallel. Will they ever intersect?
No.
No, so if I'm looking at the point of intersection, they don't intersect. What's my answer?
No solution.
No solution. We've seen that before, right? Graphing wise?
Yes.
We okay identifying that parallel lines will give us no solution for systems of equations? Do we understand why that's the case? Because they do have the same slope, yeah. So when we're solving by graphing, we're looking for the point of intersection to be my solution, right? Well, if they don't intersect, they're never going to intersect. They're never going to share a common point, so I know I have no solution for my system. Okay? So yeah, we could have identified what the answer would have been right off the bat, just looking at the slopes and y-intercepts, right? Do they have same slopes? Yeah. Do they have same or different y-intercepts? Different. I can identify that those would be parallel lines, and so that's going to be no solution. I do still want you to graph it if it asks you to solve by graphing. Okay? Like I said on the assignment, though, it's going to give you some problems that asks you to just look at the slope and the y-intercepts. Questions on solving this by graphing? Can I erase and solve it by substitution now? All right. All right, substitution. I feel like our least favorite method has been substitution. Would I be correct in saying that?
That was the one that we were just doing.
We were just doing elimination. Oh, we just now graphed. But the last thing we covered was elimination. I'd say overall, most classes struggled with substitution on the quiz. Can y'all remind me how to substitute? How to solve using substitution?
Like line up the
You have
X.
to make sure you're.
That's elimination.
you're-
Yes.
Replace the y with like the other equation.
Very good, yeah. Step 1 would be to get an equation solved for a variable, right? But that's already done for me, which is nice. Step 2, what does y equal in my first equation? 2x plus 1. Y equals that whole expression. That's what an equal sign means, right? This side of the equation is the same as this side of the equation, right? So, what can I do with the y in my second equation?
You can put
Yeah, take it out, put 2x plus 1 in its place. The rest of the equation stays the same. Equals 2x minus 5. Everyone okay with how I've substituted here? Any confusion there? After I substitute the expression for my variable, I can now solve that equation for that variable. So let's try to solve this for x. What would be my first step in doing so? Yeah, subtract 2x from both sides. Try to get the variables to the same side of the equation, right?
Oh, I thought you combined them.
Well, can I combine them if they're on opposite sides?
No.
No. I'd have to move it over using my inverse operations. Okay? So what happens when I do 2x minus 2x?
So 1 equals negative 5.
I get not x. I get 0x, which is just 0. So my x's go away.
So 1 equals negative 5.
Yeah, on the left side of the equation, I'm left with 1. On the right side, I get negative 5. Does everyone see what happened there? My x's canceled out. Okay? If that's the case, I need to look at the statement that is remaining. Is that a true or false statement? Does 1 equal negative 5? No. So what's my answer?
No solution.
No solution. If I'm solving by substitution and my variables happen to cancel each other out like they did here, I'm left with a false statement. I get no solution. That's what it looks like if you're solving it using substitution. We already knew the answer because we already graphed it, right? But that's what it looks like using substitution. Questions there? Can I erase and use elimination? See what that looks like. What form do we want them in for elimination? Standard form, ax plus by equals c. X and y on the same side of the equation, constants by themselves. Are these in standard form? No. How could I put them both into standard form though? Yeah, subtract 2x from both sides on both of them. Can I combine the 2x's with the y's? No. So up top I get negative 2x plus y equals 1. And the bottom negative 2x plus y equals negative 5. Be okay with how I've converted the standard form here? Does everything line up where it needs to go? Yes. Right off the bat, do I have same number opposite signs in front of the x's or the y's? I do not. Do I have same numbers? Yeah, I've got same numbers, same signs. So how did we handle that whenever I had same numbers, same signs? Multiply one of my equations by negative 1 to get that opposite sign in there, right? Does it matter which one is multiplied by negative 1? No. Do you want top or bottom? Top. Multiply this top equation by negative 1 to change my signs. Okay? Everything in the equation gets multiplied by negative 1. So what's negative 2x times negative 1? 2x. Positive 2x. Negative 1 times y. Negative y. Negative 1 times 1. Negative 1. Am I moving too fast for anybody? Slow down if I need to. Now do I have same number opposite signs in front of one of my variables? Yeah. After that happens, what do I do with those two equations? Add them up. Negative 2x plus 2x. 0. They're eliminated. Y plus negative y. 0. They are also eliminated. Do I have any variables left? No, there's nothing left on that left-hand side, is there? What number would I use to represent nothing? 0. Negative 5 plus negative 1? Negative 6. So kind of a similar thing that happened with substitution. My variables canceled each other out. Am I left with a true or false statement? False. 0 does not equal negative 6. So what do you think my answer is if my variables cancel each other out and I'm left with a false statement? No solution. That's what it will look like with elimination when you have a no solution problem. Okay? Any questions, comments, concerns on example 1 using any of the methods? Do I expect you to use every method on every problem? No. There's one section on your assignment where it says solve the system of equations. It doesn't tell you to use any specific method, so you get a pick. Can I move on to example 2? All right. Negative 2x plus y equals 3. Negative 4x plus 2y equals 6. Once again, we're going to solve using all three methods. we'll do graphing first. What form do we want it in for graphing? Slope intercept. I got to solve both my equations for y. Okay? Top equation, equation 1. What would be my step to get y by itself? Add 2x to both sides. Can I combine that 2x and 3? There it is in not standard form, slope intercept form. Questions on that? Okay, bottom equation. Equation 2. What's my first step to get y by itself?
Add 2.
Not add 2.
4.
Add 4x to both sides. Once again, can't combine the 4x and the 6. What's my last step to get y by itself?
You add the variables. Divide by 2.
Divide both sides by 2. What gets divided on the right by 2?
All of it.
Everything. 4x divided by 2. 2x. 6 divided by 2. 3. What do we notice about these two equations?
Well, they're the same.
They're the same. So what's my answer probably going to be? Infinitely many solutions, because they're going to be the same line. Let's go ahead and graph it though. What's my y-intercept?
2 over
3. And what's my slope?
2.
2 over 1. Which two directions? Up 2, right 1. Or down 2, left 1. Once again, go ahead and graph it if it asks you to solve for graphing. But, do I need to graph the second line? No, it's the exact same thing, isn't it? What's my answer here?
Infinite.
Infinitely many solutions. Once again, we've seen that before, right? We saw it when we solved by graphing. If you get the same line, it's going to intersect at every single point. It's infinitely many solutions.
Wait, is infinitely many solutions and all real numbers is something?
I don't like to put all real numbers. Technically, your domain and your range do cover all real numbers. But I don't like that because not every single ordered pair is a solution. Right? Is the ordered pair 3, negative 2 a solution? No. That's why I like to say infinitely many solutions. If you were talking about domain and range, yes, you would say all real numbers. Okay? Questions, what it looks like graphically. Same slope, same y-intercept, you got infinitely many solutions. Can I erase and move to substitution? We already solved our first equation for y, right? Y equals 2x plus 3. That would have been my step 1 if I was just solving by substitution right off the bat. Correct? Solve one of your equations for one of your variables. So, what does y equal here?
2x plus 3.
Y equals 2x plus 3. So what can I replace this y with in my second equation? 2x plus 3. The rest of the equation stays the same. Did I replace 2y with 2x plus 3? No, I still have to keep that 2 out front. I'm literally just taking the y out, putting 2x plus 3 in its place. The rest of the equation stays exactly the same. We good with how I substituted here? Now I can just solve this equation for x. What's my first step here? Distribute the 2 through the set of parentheses. 2 times 2x. 4x. 2 times 3. 6. Everyone good with distributive property? Once again, am I moving too fast for anybody? I feel like I'm picking up the pace here a little bit. Next step.
Wait, how did you get negative 4x plus 1x? Like,
So when I plugged in, I rewrote this equation. Negative 4x plus 2. Take the y out, put this in its place. Equals 6. Distribute here. I still have this negative 4x. 2 times 2x gives me the positive 4x. 2 times 3 gives me this plus 6. I still had equals 6. Whew. Does that make sense?
yeah, that makes sense.
Okay. Next step. Combine your like terms. I get negative 4x plus 4x. What happens there?
Cancel each other out.
They cancel each other out because that'd give me 0x, right? Or just 0. What am I left with? 6 equals 6. So similarly to no solution, my variables cancel each other out, didn't they? With no solution, though, I was left with a false statement. Am I left with a false statement here? No, I'm left with a true statement. 6 does equal 6. So what do you think my answer is? Infinitely many solutions. The variables cancel each other out. You get a true statement. It's infinitely many solutions. Okay? Questions on substitution with infinitely many solutions. Can I erase and do elimination? All right. They're already in standard form for me. So using elimination, I don't have to move anything around. Do I, right off the bat, do I have same number, opposite signs in front of x or y?
No.
No. Do I have same number, same signs? No. So I'm going to have to multiply one or both equations by something other than negative 1. Okay? Can I multiply the 2 by anything to get to 4?
Yes. Negative 2.
Yeah, I can multiply by negative 2 up top. What about 4 to get to 2? No. Let's check the y's. Can I multiply 1 by anything to get to 2? Negative 2, right? What about 2 to get to 1? No. So either way, I'm going to be multiplying the top by negative 2. Question?
Can you divide?
Yes, but I usually don't like to teach that because you'd technically be multiplying by a fraction, and most students don't like to multiply by fractions. So I usually tend to go just, can I multiply by a whole number to get to this number? That makes sense? But yeah, if you wanted to multiply the bottom equation by 1/2, go for it. So negative 2 times negative 2x. Positive 4x. Negative 2 times y. Negative 2y. Negative 2 times 3. Negative 6. Do I now have same number, opposite signs?
Yeah.
Yeah, so now I can add my two equations. Negative 4x plus 4x would give me what? 0. They're eliminated. 2y plus negative 2y would give me what? 0. They're eliminated. So what's left on the left-hand side? 0. You okay with that? Okay, what's 6 plus negative 6? 0. So once again, similarly to no solution, my variables cancel each other completely out. Am I left with a true or false statement? True. 0 does equal 0. So my answer is infinitely many solutions. That's what it would look like using elimination. Any questions on that? So, no solution. Graphing, there'll be parallel lines. Same slope, different y-intercepts. Right? If you're using substitution to solve it, your variables will cancel out at some point. You'd be left with a false statement. So no solution. If you're using elimination, once again, your variables will cancel out. You'd be left with a false statement. So no solution. Infinitely many solutions. You'll have the same line if you're graphing. Same slope, same y-intercept. If you're solving by substitution, your variables will cancel out at some point. You'll be left with a true statement. Infinitely many solutions. Solving by elimination, variables cancel each other out. True statement, infinitely many solutions. So anytime your variables cancel each other completely out, it's either going to be no solution or infinitely many solutions. You just have to identify which one. False statement, no solution. True statement, infinitely many. Does that make sense? If your variables don't ever cancel each other out, you'll just get one solution. The one ordered pair you get that the x value and the y value make up. Okay? Questions, comments, concerns about our special solutions here? All right, here we go. Here's your assignment. Pages 249 through 250, numbers 2 through 26 evens. This will be due Thursday the 9th on Canvas. Are there any questions about the notes before I end the recording?